Parabolic dish antenna is also known as a parabolic reflector antenna. That is because it uses a parabolic reflector which has a curved surface with the cross-sectional shape of a parabola. It is also often called as dish antenna and even a parabolic dish because of its shape. The parabolic dish antenna directs the radio waves received on its large surface to a focal point from where the radio waves are picked up by another smaller antenna, which could be a dipole with a preamplifier. Parabolic reflector antenna has a high gain, directivity, and a narrow beam width. For achieving narrow beam width, the reflector must be larger than the wavelength of the radio frequency. Hence, it is practical only at ultra high frequency and super high frequency or microwave ranges. Parabolic dish antennas are commonly used in satellite communications and space communications. A very common use in my region is for reception of satellite television signals. I can see a dish antenna on my neighbor's rooftop as well. Some apartments have multiple dish antennas on rooftops belonging to several occupants of the apartments. Some amateur radio operators in this region use parabolic dish antennas for working QO100 geostationary amateur radio satellite. As the uplink of QO100 is on 2.4 GHz band and downlink on 10 GHz band, parabolic dish antennas are quite suitable for them. Some of them do have setups for DATV or digital amateur television as well, transmitting live high-definition videos through the wideband transponder on QO100, while the majority are on the narrowband transponder working SSB or CW. Microwave telephone links also use parabolic dish antennas. Radio astronomy, including amateur radio astronomy and deep space network, are the other important applications with usually huge arrays of parabolic dish antennas. This image is useful for explaining the function of a parabolic antenna. Paths FP1Q1, FP2Q2, FP3Q3 are all the same length for a parabolic reflector antenna. A spherical wavefront emitted by a feed antenna at the focal point of the dish F will be reflected out as a plane wave L traveling parallel to the dish's axis VF, that is from the vertex through the focal point. The other way around, during reception, radio waves received along the axis will be focused on the focal point, accounting for the gain of the antenna. Signals are fed through a feed line to a small feed antenna located at the focal point. The parabolic reflector can be of sheet metal, screen or wire grill. Shapes could vary depending on the need to create different beam shapes. The holes in the screen are smaller than 1/10 of the wavelength so that they work just like solid metal but reduces weight and wind loading. Supporting truss is needed for large dishes, as you would have noted in pictures of radio telescopes and deep space networks.